The world of quantum mechanics is strange. It's a realm where the familiar rules of physics don't always apply. Particles can exist in multiple states at once. Information can travel instantly across vast distances. Quantum computers harness this power to perform impossible calculations. Imagine designing life-saving drugs in days, or predicting weather months in advance. This is the promise of quantum computing. At the forefront is the Zhuchangji 3.0. Developed by brilliant scientists, it represents a leap forward. It's a testament to human ingenuity. With the Zhuchangji 3.0, we enter a new era of quantum supremacy. At the heart of the Zhuchangji 3.0 are 105 qubits. These qubits are the building blocks of quantum computers, analogous to the bits in your smartphone or laptop. However, unlike classical bits, which can only be either a 0 or a 1, qubits can exist in a superposition, simultaneously representing both 0 and 1. This unique property allows quantum computers to perform calculations exponentially faster than classical computers for specific tasks. The Zhuchangji 3.0's qubits are arranged in a sophisticated two-dimensional architecture, carefully designed to maximize their stability and computational efficiency. This architecture allows for complex interactions between qubits, enabling the processor to tackle intricate problems that are intractable for classical computers. One of the key challenges in quantum computing is maintaining the stability of qubits, which are notoriously susceptible to environmental noise. The Zhuchangji 3.0 addresses this challenge with innovative error correction techniques and a novel design that shields the qubits from external interference. These advancements allow the Zhuchangji 3.0 to maintain the stability of its qubits for an impressive duration, significantly enhancing its computational capabilities. The development of Zhuchangji 3.0 marks a significant milestone in the global race for quantum supremacy. It stands shoulder to shoulder with other cutting-edge quantum processors, each vying for the lead in this exciting field. Google's Willow processor, for instance, boasts a similar qubit count to the Zhuchangji 3.0 and focuses on achieving what's called quantum advantage, the ability to outperform classical computers on specific tasks. Then there's IBM's Osprey processor, which takes a different approach by cramming in an impressive number of qubits. With 433 qubits, Osprey aims to tackle even more complex problems. The competition between these tech giants and research institutions is fierce, driving innovation at an unprecedented pace. Each of these processors has its strengths and weaknesses, and the ultimate winner of the quantum race is still anyone's guess. But one thing is certain: the rapid progress in quantum computing is pushing the boundaries of human knowledge and paving the way for a future filled with incredible possibilities. Section 4. Reshaping Our World. The Promise of Zhuchangji 3.0. The potential applications of Zhuchangji 3.0 are vast and transformative. In the realm of cybersecurity, quantum computers could render our current encryption methods obsolete, exposing sensitive data to malicious actors. But on the flip side, they also hold the key to developing new, unbreakable encryption algorithms that could safeguard our digital world. Drug discovery is another area where Zhuchangji 3.0 could revolutionize our lives. By simulating the complex interactions of molecules, quantum computers could significantly accelerate the development of new drugs and therapies, leading to breakthroughs in the treatment of diseases like cancer, Alzheimer's, and HIV. Beyond these specific applications, the computational power of Zhuchangji 3.0 has the potential to impact various fields, from materials science to artificial intelligence. Imagine designing new materials with unprecedented properties, or developing AI algorithms that can solve some of humanity's most pressing challenges. The possibilities are truly limitless. Section 5. Navigating the Quantum Future Challenges and Ethical Considerations. The advent of powerful quantum computers like the Zhuchangji 3.0 is not without its challenges and ethical considerations. We must proceed with caution and responsibility, considering the potential consequences of our actions. One pressing concern is the potential for misuse of this technology. In the wrong hands, quantum computers could break encryption and steal sensitive information. Establishing ethical guidelines and regulations is crucial. We need to ensure this technology benefits all of humanity. Another consideration is the impact on the job market. Quantum computers could automate many jobs, leading to job displacement. We must invest in education and training for future jobs. The quantum revolution is upon us, and it's up to us to ensure it leads to a brighter future for all.